Hello guys, and welcome back to another video on Doggo's channel. Today I will be telling you if the Planck length changes depending on the speed of light. So basically, the Planck length is very close to the amount light can travel in the Planck time. It is actually not that simple. The Planck length is actually the square root of the product of the reduced Planck constant times the gravitational constant divided by the speed of light in a vacuum cubed. But the Planck constant and the gravitational constant change depending on the meters, newtons, and joules per second, aka meters squared times kilograms per second. So what are they? Well, I am just going to assume that the kilograms and newtons are 1. And from this, I just used a calculator to find out that the remaining variable, meters, is 0.316243, which I do not know if this is relevant, but it is suspiciously close to the square root of 0.1, which is 0.316227766601. Okay, enough of that. The speed of light in a vacuum is not a variable and will always stay the same, so therefore the Planck length would never change. So even though the speed of light may be slower if it weren't in a vacuum, the Planck length would still stay the same. But this does not mean you could not observe in spaces smaller than the Planck length. For example, in a Bose-Einstein condensate, a light beam that enters would compress itself into a space millions of times smaller than it was, then when it exits, will expand again without losing information or changing. This means that more information could be stored in a smaller space if light was slowed down. Which also means that multiple photons would have to be inside a Planck length for this to happen. The best guess I can make is that the Planck length is the largest smallest observable length that works on photons anywhere in the universe. And this never changes. Anyways, hopefully this video answered your question, and see you next week. Bye.